Welcome to surveying class. So today we'll be discussing lecture number 12, that is permanent adjustment of level. So in the last lecture we have charted the new unit, that is the measurement of vertical distance. So in the lecture number 11 we have discussed the instrument which is required for the vertical measurement, which is called level, right? Level is an instrument by which we are measuring the vertical distances. So if you recall, in the last lecture we have discussed there are three types of levels are available. Right, first one is the dumpy level, then you have the auto level, right, and then lastly we have discussed about the tilting level. So these are the basic instruments in the leveling also. So let's get started with our permanent adjustment of level. So before we take any measurement on a field, first we have to check our instrument, which one we have, that is correct or not. So we have seen, right, so this is a tripod. So inside the tripod, this type of instrument will be mounted, right? So you have something like that shape will be there. So this is our dumpy level, or maybe any leveling auto level also you can consider. So this instrument is basically used for the vertical distance measurement, right? So before we use this instrument on a field for the vertical distance measurement, we have to first check whether the instrument is working correctly or not. Okay, that we have to check it first. If instrument is having some error, then whatever measurement if you take with the same instrument, there will be errors in the measurement, right? So this is always better to take first check whether the instrument is working correctly or not. So the instrument from the manufacturer, when you newly purchase it instrument, so normally the instrument will be working good because it is newly manufactured, and it will be working good. But after some day, after some year, what will happen? The wear and tear, all these things will be happening. Some screws will be there, right? Some screws may be loosened, or so many things may happen, right, due to mishandling. Also, some disturbance you will find in the instrument. So because of that, all the parts may not be in the not standard value. So in that case, we have to check the instrument occasionally, especially before you take any precise surveying work, to ensure that instrument is perfectly adjusted. Okay, so that's why we first before taking any measurement on a field, first we have to check our instrument is correct or not. So that we'll be checking, that we call it is the permanent adjustment of dumpy level or the leveling instrument. So what are the fundamental lines of level? So how will you check then whether our instrument is working fine or not? So as per our principle, if you see, this is a like leveling or dumpy level, if you consider, right, this is our dumpy level, and this is your telescope. Here you have the diaphragm. We have discussed in the last class in details, right, what each of this part of the instrument, right? And you have this foot screw, and this is middle, you have the bubble tube to check whether the instrument is at the level or not, right? And this is the tripod. So here if you see, we have these three fundamental lines in the instrument. What are these three? First one is, if you see this one, that is the axis of the level tube. So this is, you have the level tube, right? So this level tube axis will be there. So this axis should be always parallel to the ground surface, isn't it? So this is the first line. Second line is when you look from this eyepiece, then the line of sight where you will be looking, that should be parallel to this line, is not it? Both the lines should be parallel to each other. And thirdly, you have the vertical axis. This one is the vertical axis. This should be exactly perpendicular to this uh, line of sight as well as the axis level of tube. So these are the three fundamental lines. With these three lines, where if these three lines are perfectly in position, then means this vertical axis and the line of sight is perpendicular. This angle is perpendicular, and also the axis level, that angle also perpendicular, right? Then we can call it the instrument is at the it's perfectly adjusted. So basically in this lecture, basically we'll be seeing how we can confirm or how you can verify that all these two lines are parallel, as well as this line is vertical. So with this measurement of these three lines, you can tell which instrument is perfect. Right, now how will you measure it? If there is any disturbance, like if this line and this line is not perpendicular to each other, then in that case, how will you adjust it? So basically in the instrument, you will see many screws will be available. So here also you have one screw. Basically this screw is adjusted to this diaphragm. So this diaphragm also can move horizontally or vertically. If you lose this screw, then you can adjust the diaphragm. Also, this leveling instrument, this level spirit level whichever we have, that also has a screw attached to the instrument. So with these screws, basically we call it capsitan screw. So with this screw, basically we can adjust the instrument, and if any further tilting is required, we will do, and we will ultimately permanently do the adjustment. Okay, so these are the three fundamental lines, very much important here in the dumpy level. So now the relation among the fundamentals. Also already I have explained, in a proper adjusted dumpy level, the desired relation among the fundamental lines are, what is that, axis of the level tube is perpendicular to the vertical axis, right? So axis of the level tube, so this is the axis of the level tube, should be always perpendicular to the vertical line. So this angle we have to check it, whether it is 90° or not. This is our first one. Second one, the horizontal crosshair should be lie in the plane of vertical plane perpendicular to the vertical axis, so that it will lie in a horizontal plane when the instrument is properly leveled. That means the crosshair is there, right? So let me draw it here again. Instrument, so you have this is the instrument, it's eyepiece, right? So here you look, and this side you have the lens. So at the middle somewhere you have, here you have the diaphragm. So in the diaphragm, basically this type of crosshair will be there. Okay, so if you look from the eye side from here, you will see this type of picture inside the telescope. So this type of crosshair will be there. So this crosshair is at this point, right? So the horizontal crosshair should lie in the plane perpendicular to the vertical axis. So this horizontal crosshair line should be perpendicular to this axis, perpendicular to this vertical axis. Definitely it should be, is not it? So if it is not perpendicular, then you understand there is some issue. I mean, the instrument, some screws got loosened, or instrument is not in a perfect position. So you have to adjust the diaphragm so that this horizontal line should be perpendicular to this vertical line. The line of sight is parallel to the axis of the level tube. So this is the line of sight. Line of sight means where you are looking. When you are looking, so basically your light will always pass through the straight line, right? That is, we call it line of sight. Line of sight. Sight means by looking. When you look it in the eyepiece, the line should be exactly parallel to the axis of the level tube. The level tube we have at the top, right? So somewhere top or at the side you have the level tube. So both the lines should be parallel. This green line and the blue line both should be parallel to each other. Also, the optical axis, the axis of the object length, and the line of sight should be coinciding. Okay, so all these things you have to check it. So the permanent adjustment of the label is tested by finding the relative position of the fundamental line. So basically, before you take any surveying with the dumpy label, first make sure that these lines are perfectly aligned to each other. So basically, we are finding out the relative positions of fundamental line, and if the relative position of fundamental line is perfect, will then our instrument is correct. Otherwise, we have to do some permanent adjustment into the level. So the permanent adjustment of the dumpy level, how it is done? If any fundamental relation is found to be disturbed in a dumpy level. So if you find that two lines are not parallel, or maybe the vertical line is not exactly vertical, right? So if the fundamental relation is found to be disturbed in the dumpy level, the crosshair and the level tube are adjusted. See, crosshair I said, right? In the diaphragm you have the crosshair. So if this is the telescope, and here you have the eyepiece, and this side you have the lens, and in the middle you have the diaphragm, right? The diaphragm, in the diaphragm, basically this type of crosshair will be there, isn't it? So this diaphragm line, if this line is not perpendicular to the vertical line, then what we can do, there some screws will be there, right? So that screws will be adjusted. If you loosen the screw, then this diaphragm can be little bit moved. So once you move it and you adjust it, whether both should be in the same line or not. So the level tube will be at this position at the top. Maybe here you have the level tube. So level 2 axis also will be there. So level 2 also connected through screw. So here you have the two screw. So these two also, if this line and this line, both line are not parallel to each other, so in that case also you can adjust this screw, and you can make this level tube parallel to this line and this line. Okay. So the reference line of the adjusted dumpy label is the vertical line, which remain fixed in the direction. So with reference to, always a vertical line will be there, right? Vertical line, it will be mounted on a, mounted on a tripod, isn't it? So this is the tripod, something will be there. You have this type of tripod thing will be there, right? So this instrument will be mounted on a tripod. So this is the vertical line, is the gravity line, right? So we use this type of plumb bob. We discussed earlier also what is plumb bob. So this type of instrument will be there. This is a steel cone shape, something will be there, and this is the wire. Okay, maybe thread basically. So whenever you suspend this here, So because of this mass, always it will be acting towards the gravity. So this line is the vertical line. So this vertical line we adjust it as the center. So with this vertical line, basically we find out what is the angle with this line as well as this label tube line. So the reference line for the adjustment in the dumpy label is the vertical line, basically, which is remain fixed and is depends on the direction of the gravity. So this line will be always direction of the gravity, is not it? Because plumb bob you are keeping it, so plumb bob will be always giving the direction towards the gravity. So that is the permanentization of the dumpy level. So now you have to test it whether the angles are correct or not. So axis of the level tube is perpendicular to the vertical axis. First we check one by one, we'll do the checking. So first check we'll be doing is the axis of the level tube is perpendicular to the vertical axis or not. So how will you check it? So for example, the instrument already got damaged, means this is the true vertical line, right? This is the true vertical line, but because of instrument is damaged, the vertical line is this one, it is showing, is not it? So the vertical line is damaged. So this is the first position. So whenever instrument is in this position, so when the instrument is in first position, this angle, if you see, it is not 90 degree, it is 90 minus alpha, right? Because the error here is basically alpha. So this angle is 90 minus alpha, not alpha. So now in the again you adjust the instrument, you tilt the telescope to the second position. So the keeping the instrument in the same position, only you rotate the telescope in the second position. So now telescope's line of sight, the axis level. See, axis level initially it was this one. Now you change to this line. So this is your axis of the level tube, right? So this is again in the wrong position, right? Corrected position will be this one. Alpha is because alpha is the adjustment here, right? So that we can find it out. So after setting and labeling the label, the turn the telescope 180 degrees. So what you do, initially you set it here. So whenever you set it here, you check what is the level tube. So level tube will be something in a rectangular thing, right? So level tube, the bubble will be at the middle. So when all these three legs you adjust it, so bubble initially bubble will be in some direction, maybe initial bubble was here. So with these screws, foot screws, basically you adjust the leveling and this bubble from here to here, center it came. So center it came means the instrument is at this position, it is labeled. That's fine. So now what we do, you rotate it 180 degree. The instrument will be there, right, in this direction. Now you rotate the telescope 180 degree and check whether the what is happening inside this bubble, whether this bubble is still at the center or not, or it is tilted to some other direction. If the bubble is went to some other direction, that means you understand that there is a problem with the axis, axis of the level tube. It is not perpendicular to the length, perpendicular to the vertical axis. That means you have to remove the screws, right, and you have to adjust the level tube accordingly, because vertical line is always correct. Okay, the vertical line will be always correct because we use plumb bob, right, to check that. The only problem will be there will be problem in the axis of level tube. So axis of level tube should be adjusted by removing the screws, and then you check it. Like that the process will go. So this is the test basically you have to perform to check whether the axis of level tube is exactly perpendicular to the vertical line or not. So what are the tests? So after setting and labeling the instrument, turn the telescope 180 degrees. So again let me draw it here. So you have the telescope here, right? So this is the object piece, and here you have the eyepiece, and in the center you have maybe somewhere you have diaphragm. Okay, so this is mounted on a tripod. So something like this type of tripod will be there, right? So mounted on a tripod. Now once you level it, so here you have the bubble tube. So bubble tube means this type of tube will be there, right, where inside fluid will be there, and at the center you have the uh, bubble. So if this tube is, if this entire tube is at the level position, then what will happen, this bubble will be at the center. If one side is tilted, then what will happen, bubble will be coming in this side or this side, any one side it will be there, is not it? So initially you set the tube, you adjust the foot screw. So here you have the foot screw, 3-foot screw will be there. So with this 3-foot screw you keep the bubble at the center. Now you rotate the telescope. So initially the eyepiece was this side, now you turn this and your eyepiece will be this side, and this object lens will be in this side. So in that position, after you rotate 180 degrees, still if the bubble is at the center, then you understand that this the axis of the level tube is perpendicular to the vertical one. Okay, so if the bubble remains at the center, the axis of the level tube and perpendicular is the vertical. Otherwise, the displacement of bubble tube from the central position indicates that the tube is not adjusted. The amount of displacement is the double of the amount of the error. Okay, by the principle of uh, reversion. So in that case, you just remove the screw. So few 2 3 screws will be there which connect the bubble tube with the instrument. So remove the screw and you adjust it accordingly, and that is the settings. So first setting you have done it, that is the you checked the axis level tube which is perpendicular to the vertical axis or not. So first setting is done. So how adjustment is takes place? So step one, basically with the help of capstan screw. So capstan screw is basically which connects the level tube with the instrument. One end of the level tube is raised. So basically you loosen the level tube and then one end you raise it. Okay, or lower it as needed, whichever is needed, so that the bubble is halfway back to the central position. Then step 2, with the help of leveling screw, the other half of the displacement move further to bring to the bubble at the center. So what we do essentially, so for example, you understand now, once you rotate 180 degrees, the bubble is now moved to here. Initially, at the initial position, it was at the center. Okay, so initially it was center, now bubble came to one side. So what we'll do, first step is, so bubble is connected into the instrument, right? So here you have the screw. So you remove this screw, then you can basically move the entire instrument, and not entire instrument, not this level tube, you can move it up or down, you can do it. So in that case, what will you do? You remove the screw and then uh, you little bit you rise it. This end you little rise it. The whenever you rise, this bubble will simply come from left to right. Gradually, it starts going. So you keep it at halfway. So when from here to when the bubble comes up to this point, halfway, middle of this one, approximately when the bubble comes at the middle, so in that case immediately you stop rising or lowering and tight the screw. So now the bubble is at the half, not at the this point but at the halfway. Now remaining halfway you adjust it through the foot screw. So you have foot screw, right? So let me draw it. So this is the telescope, and then you have, this is the vertical axis. In the vertical axis also you have three screw, right? Here one, two, and three. Three screws will be there. So with this 3 foot screw, basically now you adjust the instrument and keep the bubble into center. So this step is repeated until the adjustment is perfect. So like that, basically we have to do the adjustment. So now one line we have corrected it. That is the axis of label tube. So now next axis we have to correct it is the horizontal crosshair should lie in the plane perpendicular to the vertical axis, right? Next one is the line of sight, which also should be perpendicular to the vertical axis. So how will you do that? So let me draw it again. This is the telescope, and this is the eyepiece, and here you have the diaphragm, right? And this is, and you have the objective. So object lens. So this diaphragm basically will have a crosshair, right? So this type of crosshair you will find it out in the diaphragm. So now horizontal crosshair should be in the plane of the perpendicular to the vertical axis. So this line, so this horizontal line in a crosshair should be perpendicular to the vertical line, right? Vertical axis is there at the center. So both the lines should be perpendicular to each other. That we are checking now. So how to check it? So this is the test we will do. A well-defined point is focused. So what we will do? A well-defined point is focused. So from this point, basically you focus a line. You align a line and you focus some point. Okay, this is fixed point you focused. Now what will you do? Now the object will be just exactly at the center of this crosshair. So now if you look from this side, you will see this type of crosshair, right? So whatever object you have sighted here, so that sight will be exactly at the center of this point. Now what will you do? Gradually you move this telescope, you rotate it in one direction. So whenever you rotate it, this point will simply go through the same line, right? Because it will go into the same direction. So slowly this point will move in this direction. So if the point is moving in a in this horizontal line, then you can understand that this line is exactly perpendicular to the vertical line. Okay, or if it is not perpendicular line, then what will happen? So initially this is the bubble tube and you sight it one point here. Now gradually if you little rotate the instrument, the telescope, then if ideally this point should now, whenever you rotate it, the point should move something like that. But if there is any problem in the instrument, then you will find the point will be somewhere like that. If both the line are not perpendicular, then the point will be above or below or any position, not in the horizontal line. If it is at the horizontal line, means if the point is also moving towards this horizontal line, then you understand the instrument is fine. If it is not moving towards the horizontal line, if it is up, down, anywhere, then you have some error in the instrument, you have to correct it out. Okay, so in that test, basically you can find it out whether this two line is perpendicular to each other, no, the horizontal axis as well as the vertical axis, right? Horizontal axis is the crosshair and the vertical axis is horizontal, it's perpendicular or not. So if it is not perpendicular, then how will you adjust it? So basically one screw is there in the, so let me again draw the telescope here. So here you have the diaphragm, right? That means the crosshair is not perpendicular. So in that case, here you have the screw, one screw is there, capstan screw, more capstan screw will be there. So you remove the screw, then you little bit tilt the diaphragm so that all the lines, all this line should be perpendicular to each other, right? And always you check the new point, x point, there is which point you have cited here, this point is in this line or not. So if it is in line, if you rotate the telescope, this, if the point x is also moving towards this line, horizontal line, then the instrument is perfect. So like that we can actually test it, and if it is not perfect, then we can adjust it through, through losing those screws, right, capstan screws. So now the last check we have to do it is the line of sight is parallel to the axis of the bubble tube or not. So line of sight means what? That from there you look it, right? That is, this line is perpendicular, parallel to the axis of the bubble tube or not. So bubble tube will be here, right? Let me draw it here. So bubble tube will be at the top here. So bubble tube also has axis. So this line and this line of sight both should be parallel to each other. So if it is not, then there will be a problem. There is a problem in the instrument, and you have to rectify it accordingly. So how to test it? So that is we'll be seeing now. So in this, for this test, what we have to do is we need two peg. Two peg is required. So one peg will place it at A, and another peg will keep it at B, and A and B is approximately 60 to 90 meter distance. You can imagine, and I mean, you go to ground and take 2 points A and B. Okay, so A and B distance maybe 60 to 90, any value you can choose it, so that's fine. So now they keep the instrument at the center, approximately center, and then the same line. So if you join the both points, so in the joining line only, in the same ranging, you keep the instrument at this middle. Now what will you do? Now with this instrument, you keep a staff here. We have discussed in the last class what is staff, right? This is a vertical scale will be there, right? So one staff you keep it here, and with the instrument, if with the line of sight you check what is the reading here. So maybe for example you got some reading that is A. Okay, so this reading is A. So A means this height. Okay, so this height is A. Now again you rotate the instrument 180 degree, and from there you take the measurement. What is the height here? Now again you put this one more stuff here at B and check what is the line of sight, which line you are sighting. So that distance is B, right? Then A and B you know. So now you understand which point, what is the level difference between A and B. So if you do A minus B, if you do, then you will get what is the level difference between A and B, whether A and B are in same height, or A is at the valley top, at the hilltop, or B is at the valley down. Okay, so if what is the relative position of A and B, that you can do it A minus B. If A minus B is equal to 0, that means A and B both are in the same line, same level, basically A and B. If A minus B is positive, that means A is little higher location than the B point. Okay, So like that, a minus b basically, if you do it, so a minus b is equal to h, right? So now you understand. Now next, this is one step you got it. A minus b is equal to some h value, you got it. That's fine. So now you shift the instrument from here to here. Maybe some d1 meter distance from the A point, you keep the instrument now. Current position is here. So now from this position, again you put the peg here and find out what is the staff reading. So now staff reading is C. Now again you put another staff here, and from there again you keep the line of sight and check what is the staff reading. So now staff reading is D, is not it? So now if you do it, C minus D, so C is here and D is here. Okay, so now if you do C minus D, that will give you the level difference, right, between A and B. So that value, so earlier already you have measured A minus B is the level difference between A and B. And now you shift the instrument to some other location and you measured again what is the C and D. So C minus D will give you again the level difference between A and B. So if A minus B is whatever value you get it and C minus D both are same value, then the line of sight is perfect. There is no problem in it. So line of sight is exactly perfect. That's why both the level difference you got it same. If both the level difference is not same, so in that case the line of sight is not perfect. See the dotted line. So dotted line is the actual horizontal line, but the blue solid line, if you see, the line of sight is not exactly parallel to the horizontal line. It is, there is some downwards inclination of this line of sight because of the length is increasing, right? So because of that, here also you get the less reading. The original reading is up to dotted line, but you get up to solid line. So the reading is wrong. So if A minus B and C minus D are not same, equal, then you understand now this line of sight is not exactly vertical and exactly horizontal. There is some change, right? So now with this test, two peg test basically, you find it out that there is a issue in the instrument. Now we have to rectify it. So how will you rectify it? So you have to rectify it again. You find it out how much error is there. So A minus B is maybe A minus B is equal to H, for example, and C minus D is equal to H dash. If H and H dash both are equal, then the fine instrument is fine. If it is not equal, then there is error, right? H minus H dash is the error. So H minus H dash is the error in the total D meter distance. So you measured from A to B, right? So A to B is capital D. Horizontal distance is capital D. So you got error H dash minus H in the capital D distance. So now you have the instrument in new position is here, D1. So in the D1, how much will be the error? Now easily you can compute using the arithmetics, right? So at D1 dash distance, so this is the D1 dash, right? Sorry, at the D, not D1. At D distance, the error is, at D distance, error is basically H dash minus H. Then at one distance, error will be arithmetic, simple arithmetic we are doing, H dash minus H by D, and at new position is D1, right? So at D1 for distance, the error will be this multiplied by D1. So that much is the error in this position, in the new position, in the X position. Okay, so now you know how much is the error. So you keep the line of sight accordingly, and there will be screws in the telescope as well. So you loosen those screws and you adjust the line of sight. You make this correction in the spec, and again you tighten the screws, so the correction will be done. So like that, basically we can check the permanent settings in the instrument, that is the dumpy level. So what are the what are the checks we have done it? First one is the line of sight, that is bubble tube. It should be parallel to the line of sight, and also the vertical axis should be perpendicular to both of the lines. So these are the three checks basically you have to do it while checking the permanent adjustment. So now how to do the adjustment already I have explained you. So step one is first you find it out what is the H minus H, this error, right, which is nothing but A minus B minus C minus D. So once you have it, then already I have explained the entire step. Like then you have find it what is the E2. E2 means error occurred at the distance of D. That is E into D2 minus D2 by D. Already arithmetic I have done it in the last slide. So same thing. And then ultimately it got adjusted. So now let's solve one problem, then the concept will be clear to you. Okay, so what is the question here? So a dumpy level was set up midway between two peg 100 meter apart. So let me draw the diagram also same time. So you have two peg, one peg is at A and 100-meter distance another peg you have. So 100-meter distance, for example here. So you have another peg B. So this distance is 100 meter. So that is given. So this A to B distance is 100 meter. That's fine. The reading on the stuff at the two peg is this and this respectively. So dumpy level you set up in the midway, right? Midway means at the center. So now dumpy level you have set up at the center. So let me draw it here. So here you have the dumpy level. So with this dumpy level now you measured what is the height. You kept a staff here and you took what is the reading here, and you kept another staff at this point and you took what is the reading here. So this reading is given to us 1.650 meter, whereas this reading at B reading it is 1.21 meter, right? 1.21 meter. So that means what is the level difference now? Means what is the level difference between A to B? So the level difference between A to B will be, let me write it here. So D equal to 1.65 minus 1.21 meter. So that is the level difference between A to B. So this value comes out to be 0.44 meter. Okay, so 0.44 meter. So now you understand A to B distance is, A and B is not at the same level. So A is little, B is little higher distance. Is not it? So B is little up compared to A, and this is the difference. That's fine. So next line you read now. The instrument was then moved 10 meter ahead of second peg. Now you moved this instrument from here to second peg, means this B is the second peg. Now the instrument came from this point to this point. Right, and this distance is a 10 meter ahead of B. Now the instrument is here. Right, in a line of two peg, in the same line, basically in the same line you kept it 10 meter. So the respective staff reading, now from there if you try what is A location, from there you cite it out what is the A reading, and that A reading you find out 1.405 and the B reading you find it out 0.935. Right, then what is D dash now? Now what will be the level difference now in the current position, A and B's level difference? This will be 1.4 minus how much? 1.4 minus 0.935, is not it? So that is our D dash. So if you compute this D dash value, how much it will be coming? Check it. So this is not 0.44. You check it how much it is coming. So if you subtract it, this will be 0.47 meter. See, now at the first position, when you kept the instrument at the center, that time the level difference was 0.44 meter. But now when you shift the instrument from this middle position to here, now the level difference between A to B is now 0.47. So both are not same, right? That means there is an error in the horizontal side. Now this concludes that there is a error in the horizontal side. Now we have to rectify it. So okay, so now how to rectify it? So now what is the, how much is the error? So error is basically this minus this, that's d dash minus d. So d dash minus d is the error, E equal to d dash minus d, which is comes out to 0.03 meter, is not it? So 0.03 meter is the error, while the distance from A to B, sorry, from B to this tag is 10 meter, right? So when you have 10 meter, sorry, not 100 meter, this is 100 meter. So when you have the 100 meter apart A to B, then the error is 0.03, right? But now currently the instrument is at 10 meter, right? At 10 meter distance. So in the 10 meter distance, how much will be the error? So same thing you can do it. When the distance is 100 meter, the error was 0.03. So when the instrument distance is at 1, then it will be simply trigonometry 0.03 by 100. When the instrument is at the 10 meter, then this will be multiplied by 10. So this comes out to be 0.003. So the error at this point at the distance of 10 meter is 0.003. So this is the already we computed. See, d value is 0.003. Same thing where I am solving it here. So now the reading, whatever you got it, 0. So when the instrument is at this point, you've cited B and the reading you got it 0.935, right? 0.93 is not correct because we understand there is an error in the reading. So what is the corrected reading? Corrected reading will be this minus error at the 10 meter, 0.003. So the corrected reading will be 0.935 minus 0.003, which is comes out to be 0.932 meter. Okay, so now what do? You adjust you remove the screws. So you have the screw, right? So you remove this screw and you adjust the line of sight such that this distance. So when the instrument is at here, you find out what this distance should be 0.932. So once you get 0.932, you tighten the screw and instrument is now adjusted. So that's how basically we do the correction or the permanent adjustment on site. So till now in the unit 4, what we have discussed, we have started the new unit, right? The vertical distance measurement. So in the last lecture, we have seen the instrument which is used for the labeling, that is dumpy label and the auto label, right? These two instruments are basically used for the leveling purpose. So in this lecture number 12, basically we have discussed about the permanent adjustment, like the instrument won't be always correct. So how to check whether instrument has any errors or not, and if any error is there, how to rectify it, that also we have seen in this lecture in details. So now in the next lecture onwards, we'll be starting our vertical distance measurements. Till now we have not taken any vertical measurement yet. So we are just taking, first lecture we have seen the instrument. So in this lecture we have seen the any permanent adjustment, means if the instrument has any error or not, that we have checked in this lecture. So in the upcoming lectures we'll be discussing more about how to take the vertical distance measurement using the dumpy level. Thank you.